Three-dimensional geometry, Kcse 2017, question number 20. The figure below represents a cuboid ABCDEFGH in which AB is equals to 16 centimeters, BC is equals to 12 centimeters, and CF is equals to 6 centimeters. So the figure is there. Part A of the question, name the projection of the line BE on the plane ABCD. Name the projection of the line BE on the plane ABCD. So the first thing you're going to do is to draw line BE. So line BE, let's draw that line. So that is the line BE. We need to get its projection. Now to understand this, the projection is the shadow of line BE on the plane ABCD. So when you're getting the projection, look at point E. Point E will be projected to D. So this point E will be projected to D, and then B will remain there. So therefore, the shadow of BE on the base, that is ABCD, will be this line, that is BD. So that will be the projection. So therefore, the projection will be BD. BD. So that is how you work out the first part. Let's go to the second part. Part B, calculate correct one decimal place. 1, the size of the angle between AD and BF. AD and BF. So let's go to the diagram and identify AD. AD. So you can see AD. AD is here. So this is the line AD. And BF. We have BF is here. So BF is here. So let me draw BF. So that is BF. So you're getting the angle between, these are skew lines, lines that do not meet. So AD is here. Then BF is there. So what you do in that case, you simply need to translate line BF on to the other plane, that is AHDE. So when you translate this line is similar to the line that you're going to draw here. So let me draw it. So this line. So when you look at these two lines, AE and BF, those lines are similar. So to get the angle between AD and BF, you simply need to translate BF so that you can bring it where we have this line AD, and when you translate it, that will be the line. Now you have AD and you have AE, that is the line. So therefore the angle that you require is this angle that is here. So this is the angle. So you need to get that angle. That is the angle that you require to get. And it is very easy because you just need to extract this triangle here. Extract this triangle. So you have this measurement as 12. So this one is 12. And this one is 6. And this angle here is 90. So just use trigonometric ratios. Which one do you use to get angle theta? So tangent would work. So you get tangent of theta. So tangent of angle theta is equals to the opposite side, which is 6, divided by, so the opposite side is here, then the adjacent is here. So that will be 6 divided by 12. So this will be 6 divided by 12. And to get theta, you get the tan inverse of both sides. This will be tan inverse of 6 divided by 12 will be 0.5. So this one correct one decimal place, you'll get 26.6 degrees. So that is how you get the first solution. Part 2, the angle between line BE and plane ABCD. The angle between line BE, so let's go to the diagram. Line BE. Line BE is drawn, it is here. So this is the line. And the plane, that is the angle between a line and plane, that the base, that is ABCD. The plane, that is ABCD. That is the base. Is the base. So that is the angle between a line and a plane. To get the angle between a line and a plane, we usually get the angle between that line and its projection on that given plane. For the first part, we got the projection of line BE on the plane ABCD, and the projection was BD. So the projection of this line BE on the plane ABCD was BD. So the angle between a line and a plane is given by the angle between that line, which is BE, and its projection on that plane. The projection is BD on the plane ABCD. So the angle that we require to get is this angle that is here. And to get that, we are going to use this triangle, this right angle triangle, triangle DEB. So DEB, it is right angled at point D. So we already have one side, which is DE6. So we need to get BD. Now to get BD, we are going to consider triangle ADB. That triangle is right angled at A. It is right angled at A. Remember, the base is a rectangle, and therefore angle A is 90 degrees. Therefore, you have ADB as a right angle triangle. So therefore, the hypotenuse is DB. So DB is the hypotenuse. That is the side opposite the right angle. DB is the hypotenuse. So to get DB using triangle ADB, which is right angled at A, we are going to use Pythagoras theorem, that is a 16 squared plus 12 squared. You get the square root of that. And this will give 400. And when you get the square root of 400, you get that one as 20 centimeters. So therefore, DB is 20 centimeters. Now in this triangle, in triangle DBE, we have now two sides. We have this side as 20 and we have this one as 6. We are looking for this angle. So we can get that angle easily by using tangent. We have the opposite, which is 6, divided by the adjacent, which is 20. So therefore, theta, so tangent of theta is equals to opposite. You come back here. Opposite is 6, adjacent is 20. Opposite is 6, adjacent is 20. So theta, therefore, you get it by getting the tan inverse of both sides. The tan inverse of 6 divided by 20. And this one will give, correct one decimal place, this will give 16.7 degrees. So that is part 2. Part 3, the angle between planes HBCE and BCFG. The angle between planes HBCE, we identify that plane, HBCE. So I have to clear everything here so that we can avoid confusion. So let me identify that plane. The plane is HBCE, CE, HBCE. So you have HB, it's there, CE. So I'm identifying that plane. So that is a plane. And which other plane? This is BCFG. 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 Here it is. BCFG. So we're supposed to get the angle between those two planes. To get the angle between two planes, first thing you identify is the point or the line of intersection of the two planes. The line of intersection of the two planes is BC. BC, as you can see, this is the line of intersection. So we draw perpendiculars or normals from each of those planes to the line of intersection. This is how we do it. When we consider the plane BCHE, we draw a perpendicular to the line of intersection. This is how we do it. So I draw, this is the midpoint, so I draw a perpendicular like that. That is a perpendicular to the line of intersection. Then I also draw from the other plane, I also draw perpendicular to the line of intersection. That is the perpendicular talking about. Is going to meet that line at 90 degrees. The angle between the two perpendiculars, that you have drawn, which is this angle here, that is the required angle. So this is the required angle. This is the required angle. I repeat that. When you're getting the angle between two planes, you draw perpendiculars from each plane to the line of intersection of the two planes. I have drawn the first one. This is the line I've drawn, perpendicular from this plane to the point of intersection of the two planes. Then from the other plane, this is the perpendicular. So where the two perpendiculars are meeting, this is the required angle. So in order now to calculate that angle, you need to complete this triangle. So I have to draw this line here and let me complete it properly. So that is the line that you draw. And there's something that you notice, that this one is forming a right angle triangle. Look at this triangle here. That is a right angle triangle at this point. So this is the required angle that you need to get. So this distance here, this distance is equivalent to 16. That distance is equivalent to 16. That is 16 centimeters. And then this distance that is here, we have a distance here. This one is 6 centimeters. So with that, we'll be able to get this angle. And the trig ratio that you're going to use is opposite of adjacent. The opposite side is 16, adjacent is 6. So tan of theta, again, we are going to use a tangent. So tangent of theta is equals to opposite, which is 16, and the adjacent is 6. Adjacent is 6, as you can see. Adjacent is 6. So this will give theta as, you get the tan inverse of 16 divided by 6 directly using a calculator. And this one will give the angle as 69.4 degrees, correct to one decimal place. So that is how you work out part 3. We go to the last part. The last part is C. Point N is the midpoint of EF. Calculate the length BN, correct to one decimal place. point N is the midpoint of EF. Point N is the midpoint of EF. So let me clear everything here so that I can indicate that. So point N is the midpoint of EF. So that is the midpoint of EF. So you're supposed to calculate BN. So let me draw BN. You're supposed to calculate that length, correct to 1 decimal place. Now to do that, we'll first need to get the projection of N to the bottom plane, that is ABCD. And the projection will be this, projection of N will be there. Just perpendicular, to be perpendicular. And then from this point, we can join like this, and we can let this point be denoted by, let's say, letter M, this point. So this will be 90 degrees. That is a point. So let me draw it properly. Let me draw it properly like this. It's supposed to be like that. So this is 90 degrees, and I call this point, which is the midpoint of DC as well. So M will be the midpoint of DC as well, and N is the midpoint of EF. I've just given M as the projection of N. Now having these, just look at that triangle and look at the side that you have. The only side that I have is this, which is 6. NM is 6. So in order to get BN, because you can see BMN is a right angle triangle, I need to get BM. So how do I get BM? To get BM, you already know that this is, look at this, look at BMC. BMC is right angled at this point, and CM is half of AB, which will be 8. So that will be 8, and this side will be 8, because AB is 8 and AB is 16, as you can see, which is equivalent to DC, which is 16. But since M is the midpoint of DC, so this will be 8 and this one will be 8. So having this triangle here, it is possible to get MB. So let me get MB. MB using Pythagoras theorem. MB will be the hypotenuse, the side opposite the right angle. So it will be 12 squared plus 8 squared to get the square root. It will be keen here. So this is a 12 squared, it is here, and then 8 squared. This is the MB is the hypotenuse. And this one will give, when you work out using a calculator, you'll get 14.4. So this is a 14.4. Now in this triangle here, this triangle, we have, so in this triangle here, we have two sides. MN is there 6, then MB is 14. So we can get BN. BN will be the hypotenuse. BN will be the hypotenuse. And that one will be given by, so BN will be given by, we just work out, BN will be given by 6 squared plus 14.4. 6 squared plus 14.4 squared, you get the square root. That is Pythagoras theorem. And when you work out these using a calculator, you'll get this one as 6 squared plus 14.4 squared, get the square root of everything. You get this one as 15.6 centimeters. And that is how you're supposed to solve that question on 3-dimensional geometry.